In the series Advanced Mathematics, we are going to start now the lecture 2 of the chapter Vector Calculus, and in this lecture we will talk about the gradient. So, first of all we have the definition of the gradient. So, before we start this chapter we talk about certain notations. So, we are saying the partial derivative that we have already studied, it is del by del x, say we are saying partial derivative with respect to x. We generally call this symbol as curly. When we are talking about this symbol, this is the symbol for del, and this symbol we are using, it is for delta. So that the confusion is not there, I am explaining that these three symbols I am using in this way. So suppose we have a scalar point function phi, it is defined at the points x, y and z. We know what scalar point function is. We are saying phi is defined from r cube to r, it is the scalar field. So we are going to talk about the differentiation of this function. We are talking about the basically the space derivatives. So we are going to define an operator that is called the del operator, and it is defined like I cap curly by curly x plus j cap curly by curly y plus k cap curly by curly z. Now how this operator acts on this function phi? We are saying del vector phi, this is called the gradient of phi. This term, when the del operator is acted upon the scalar point function, we call it the gradient of phi, that is equal to I cap curly by curly x phi plus j cap curly phi by curly y plus k cap curly phi by curly z. So this is called the gradient of phi. This is called the gradient of phi. Now based upon this, first of all we are going to talk about that what is the physical meaning of the gradient. So suppose we are saying that we have two level surfaces, we are talking about, suppose I am considering the level surfaces as two planes. We can also consider the level surfaces in this way as shown in the figure. We are saying this is one level surface, this is another level surface. So level surface we already know, it means we are saying the value of the scalar function on this surface, it is phi, is equal to c, and there is another level surface, the value we have over here, it is phi plus delta phi is equal to some constant. These are the two level surfaces. It is up to you that how you want to consider these surfaces. You can consider them as plane, you can consider them as these curves. Now suppose we have taken a point P on this level surface, this is the point P, and the position vector of this, it is r vector. We have considered another point, this is the point Q on this surface, and its position vector, it is r vector plus delta r vector. This is Q, it is r vector plus delta r vector, and this is P. Now if we join both these, we are saying this vector QP vector, we are saying it is, or PQ vector if we are writing, it is basically delta r vector. This is delta r vector. Now we are going to calculate the value of gradient of phi. We are going to calculate the value of gradient of phi dot delta r vector. We are interested in finding what this gradient of phi is. So we have taken its dot product with delta r vector. So the answer that we obtain from this dot product, it is curly phi by curly x into delta x. Delta r means its value is delta x I cap plus delta y j cap plus delta z k cap. We are saying it is curly phi by curly x into delta x plus curly phi by curly y into delta y plus curly phi by curly z into delta z, and this is basically the total derivative. We can write it is delta of phi. This is the value of delta phi. So what we have obtained from this is that, I am writing it again over here, that del vector phi dot delta r vector is equal to del phi, delta phi. Now, if we consider this point Q on this surface, we consider that this point Q lies on this surface. We are saying this point Q is over here. Its coordinate are r vector plus delta r vector. Then clearly this vector we are saying, this vector delta r vector, we are talking about if Q lies on the surface phi, then we are saying that delta r vector will lie on the surface phi is equal to c. And if it lies on phi is equal to c, it means that we are considering over here that the value of delta phi that is equal to 0. Look at this value. We are talking about two surfaces. One is phi is equal to c, second is phi plus delta phi is constant. So we are talking about that delta phi is equal to 0 when this point Q it lies on the surface phi is equal to c. So in that particular case, we obtain that delta vector phi dot delta r vector is equal to 0, and this implies us that delta vector phi is perpendicular to delta r vector on at the point P on the surface phi is equal to constant. We are saying both these vectors, these are perpendicular to each other on this surface. So what we obtain is the direction of gradient of phi. The direction of gradient of phi, it is basically the perpendicular to the surface phi is equal to c. This is the direction of gradient of phi, and if we write this perpendicular direction as n unit cap, it is the normal direction to phi is equal to c. What we obtain from this is that the value of gradient of phi that is equal to magnitude of gradient of phi. We are saying this is equal to magnitude of gradient of phi into n cap, where n cap is the unit normal drawn outward to phi is equal to c at the point P. So we have obtained that the direction of the gradient, it is normal to the surface. Next thing we are going to discuss is the value of this gradient, the magnitude of this gradient. So we are saying, again we are considering, suppose these are the two level surfaces we are talking about. Now the point P is there on this surface. We have the point P over here on this surface. It is r vector. We have drawn normal at this point. Its direction is n cap. And the point where it meets this second level surface, this is phi plus delta phi. We are naming this point as M. Now, the value of Pm, we are saying this is basically delta n, it is in the direction of the normal. So, if we calculate the rate of change of phi, the rate of change of the value of phi in the direction of this normal, we are writing it is curly phi by curly n, that is equal to limit n delta n tends to 0, delta phi by delta n, and we can write this is equal to limit delta n tends to 0. This value we are having, it is gradient of phi dot delta r vector and upon delta n, and this is equal to limit delta n tends to 0. What is gradient of phi? We are talking about gradient of phi, its magnitude into the normal vector dot delta r vector divided by delta n. Now look at this term, we are talking about n cap dot delta r. So this is basically, this term we are talking about. This is basically the projection of delta r vector along the normal, and this value we are saying this is equal to delta n. So we obtain that this is curly phi by curly n, that is equal to limit delta n tends to 0. This is gradient of phi, its magnitude of this, dot delta n by delta n. So this is equal to magnitude of gradient of phi. So what we obtain is that the magnitude of gradient of phi, it is curly phi by curly n, that is, it is the rate of change of phi along the normal. So we have obtained that gradient of phi is a vector quantity. This is a vector quantity. The magnitude of this, it is giving us the rate of change of phi along the normal, and the direction of this vector quantity, it is the direction of the unit normal. So this is the physical meaning of gradient of a scalar function. Now next we have is the directional derivative. So again we are considering that we have a level surface. This is the level surface. We are saying it is phi is equal to c. There is another level surface. We are talking about it is phi is equal, phi plus delta phi is equal to a constant. We are considering 2 points over here. One point we are considering it is P on this surface. We have considered the point Q on this surface. We have drawn the normal from P, and the point where it intersects, we are naming it as N. These are same as we have discussed in our previous slide. We are saying this value we have it is delta n, this value we have it is delta r vector. This is the direction of the normal at the point P on the level surface phi is equal to c. Now the rate of change of phi, we are saying the rate of change of phi in direction of PQ vector. PQ vector is any vector given to us. If we are saying that we are calculating the rate of change of phi in direction of PQ vector, so that is called the directional derivative of phi in direction of PQ vector. So we are saying this is the definition for the directional derivative. We are saying it is, this thing is explained over here, the rate of change of phi in the direction of PQ vector is called directional derivative of phi in the direction of PQ vector. So we are basically interested in calculating the value of del phi by del r, or we are calculating curly phi by curly r, and we are saying this is equal to limit delta r tends to 0 delta phi by delta r. Now if we talk about this vector PQ, its value is delta r vector, and this delta r vector, suppose we are writing it is equal to delta r into n cap dash, where this is the direction of this vector. The direction of this normal vector, it is n cap, direction of this r vector, it is n dash cap. So if we talk about the value of delta n, that we know it is the projection of delta r vector in direction of n cap. This thing we have already seen. So we are saying this is equal to delta r n cap dash dot n cap. So from this we obtain that the value of 1 by delta r, that is equal to n dash cap dot n cap over delta n. Now if we substitute this value, this is delta r over here, if we substitute this value in this equation, we obtain this is equal to limit delta r tends to 0, or in place of r now it is delta n tends to 0. Over over here we have it is delta n tends to 0, and we have it is delta phi by delta n into unit normal into n cap, and this value is equal to, we are saying this value is equal to delta phi by delta n unit vector dot n dash cap. Now look at this value. This is basically the definition of the gradient of phi. So we are writing this is equal to gradient of phi dot n dash cap. So what we have obtained is that curly phi by curly r, that is equal to gradient of phi dot n dash cap. So we are saying that the directional derivative of phi in the direction of n dash, what this thing represents? It represents the projection of del phi in direction of the radius, the vector PQ vector we are saying. But what we have is that del vector phi dot n dash cap, it is always less than modulus of del phi, the gradient, the amplitude of the gradient of phi. So we are saying that the gradient of phi, the magnitude of this, it gives us the maximum directional derivative. So we have obtained two things from this derivation. First is, if we have to calculate the directional derivative, it means we have to calculate the gradient of phi and we have to find its projection in the direction in which we want to find the directional derivative. And second thing we have seen that the maximum directional derivative we have, it is basically the amplitude of del, that is gradient of phi or magnitude of gradient of phi. Now next we have is the equations of normal and the tangent plane. So suppose again we are considering a level surface. We are saying this is the level surface, we are saying it is phi is equal to c, and there is a point P on this level surface. This is the point P, its position vector it is r vector. Then we are saying the gradient of phi at P, that is equal to curly phi by curly x at P I cap plus curly phi by curly y at P j cap plus curly phi by curly z P k cap. This is the gradient of the function phi at the point P. Now if we talk about the normal to this P, we have drawn a normal to this P and we have taken a point on this normal as q r vector, its position vector we have taken in this form. Then we are saying that the position vector of PQ vector, that is equal to r vector minus r vector, and the direction of this PQ vector, it is along this normal. So the equation of normal we obtain, the equation of this normal we obtain, it is r vector minus r vector. It is in the direction of the normal. Direction of the normal means we are talking about this is the gradient gives us the direction of the normal. So it is lambda times gradient of phi at the point P. And when we are talking about the tangent plane, we are talking about the tangent plane at this point, we are saying in that case we have r vector minus r vector dot, it should be perpendicular to this at P, this is equal to 0. So we are having these two equations. This is the equation of the normal and this is the equation of the tangent plane. Now if we write these values in the Cartesian form, we obtain the answers in this form, that it is x minus x over curly phi by curly x, that is equal to y minus y over curly phi by curly y, that is equal to z minus z over curly phi by curly z. And similarly, we are saying that the equation of the tangent plane, it is this. This is the equation of the tangent plane. So these are the equations in the Cartesian form. These are the equations in the vector form. Now next we have is the angle between two surfaces. So we are saying, suppose we have two surfaces and they are intersecting. So to find the angle between them, we are saying that we have at this point P, we have drawn the normal to this surface. We have drawn the normal to this surface. So the angle between their normals, that is basically the angle between the two surfaces at the point of intersection P. So we are saying, suppose this, it is phi 1 is equal to C and this is phi 2 is equal to C. These are the two surfaces. Then the direction of the normal, it is given by gradient of phi 1 and this is given by gradient of phi 2 at the point P, This gives us the normal, direction of the normal, they are the direction of these gradients. So these are not the unit vectors basically. So if we have to calculate the angle between these two, we are saying that is equal to cos inverse of gradient of phi 1 at P dot gradient of phi 2 at P divided by, we are saying, the magnitude of gradient of phi 1 at P, magnitude of gradient of phi 2 at P. So this is the value of the angle of intersection of the two surfaces at the point P. Next we have certain problems based upon these results that we have discussed. So first is, if A vector is equal to this, value of phi is given to be this, we have to calculate the value of A vector dot gradient of phi. So first of all, we are calculating the gradient of phi. So gradient of phi is equal to the derivative with respect to x, it is minus 3x square y I cap. Then derivative with respect to y, it is plus, it is minus x cube j cap, and last it is plus 2 times k cap. This is gradient of phi. Now if we take the dot product with A, we are writing the value, it is 2x square I cap minus 3yz j cap plus xz square k cap dot minus 3x square y I cap minus x cube j cap plus 2k cap. Now the dot product of these two, it is equal to minus 6 x raised to the power 4y, then we have it is plus 3x cube yz, and then it is plus 2xz square. Now if we substitute the point 1 minus 1 over here, the answer we obtain, that is equal to 6 minus 3 plus 2 is equal to 5. So this is the value of the term A vector dot gradient of phi. Next we have to calculate A vector cross gradient of phi. So to calculate the cross product, we are going to write it is I j k. The values we have, it is 2x square minus 3yz xz square, and then it is minus 3x square y minus x cube and 2, and we have to evaluate this at the point 1 minus 1 and 1. So if we substitute these points over here, this will become I j k, then it is 2 3 1, 3 minus 1 2, and on solving this we will obtain it is 7 I cap minus j cap minus 11 k cap. So this is the value of this A vector cross gradient of phi at the point 1 minus 1 1. Now next we have is, find f of r such that gradient of f is equal to r vector over r raised to the power 5 and f of 1 is equal to 0. So before we start solving this, we are writing that the value of r square we have, it is x square plus y square plus z square. If we take partial derivative with respect to x, we obtain 2r curly r by curly x is equal to 2x. So this implies us that curly r by curly x is equal to x by r. Similarly, curly r by curly y is equal to y by r, and curly y by curly r by curly z is z by r. Now coming to this question, we are writing it is gradient of f. We can write it is this r vector, we can write x I cap plus y j cap plus z k cap. So we are writing it is sigma I cap x over r raised to the power 5. We can write this is equal to sigma I cap. We want to use this result. So we are writing it in the form 1 by r raised to the power 4 x by r. So this is equal to sigma I cap 1 by r raised to the power 4, and the value we have over here, it is curly r by curly x. Now we can write this is equal to sigma I cap curly by curly x, it is 1 by r raised to the power 4 curly r. We are saying this is equal to minus 1 by 3r cube. So what we are saying, that the function f we have, that is equal to minus 1 by 3r cube plus some constant c. This is the value of f of r that we have. Now it is being given that f of 1 is equal to 0. So if we substitute this value over here, we are saying f of 1 that is equal to 0, that is equal to minus 1 by 3 plus c. So this implies that c is equal to 1 by 3. So the function we obtain, this implies us that f of r that is equal to minus 1 by 3r cube plus 1 by 3. So this is the required function f of r. Next is find the values of the constant lambda and mu so that these two surfaces intersect orthogonally at the point 1 minus 1, 2. So these two surfaces, they intersect orthogonally, means that the angle between them, it is 90 degree. So the cos of 90 we know it is equal to 0. So we are saying that the value of gradient of phi 1 at the point P, we are saying suppose this is the point P, dot gradient of phi 2 at the point P divided by the amplitude of both these values is equal to 0. So we are saying that the dot product of these two values is 0. So if we calculate the gradient of both these functions, the gradient of this first function, we are writing it is lambda x square minus lambda plus 2x minus mu yz is equal to 0. This is the function phi 1. Phi 2 is the function, it is 4x square y plus z cube minus 4 is equal to 0. So if we write the gradient for both these terms, we are saying for gradient of phi 1, we are having the value, it is 2 lambda x minus lambda plus 2 this whole I cap minus mu z j cap minus mu y k cap. If we substitute the value that is given to us, it is 1 minus 1, 2. In this, we obtain this is 2 lambda minus 2 times I cap, then it is minus 2 mu j cap, then it is plus mu k cap. So this is equal to lambda minus 2 I cap minus 2 mu j cap plus mu k cap. Similarly, if we calculate the value of gradient of phi 2, the answer we obtain, it is equal to 8xy I cap plus 4x square j cap plus 3z square k cap. So it is equal to, if we substitute the value 1 minus 1 and 1 over here, we are saying gradient of phi 2 at the point P. The answer we obtain, that is equal to minus 8 I cap, then it is plus 4 j cap, and last we have it is 12 k cap. Now, if both these surfaces they intersect orthogonally, it means that this point we are saying it lies on this surface. This point it lies on this surface. It means it will satisfy the equation. So what we are saying, it is lambda into 1 minus mu into yz, it is minus 2, that is equal to lambda plus 2 into x is 1. So this lambda gets cancelled and we obtain the value of mu is equal to 1. We obtain the value of mu is equal to 1. Now if we substitute the value of mu is equal to 1 in this equation, we obtain it is lambda minus 2 I cap minus 2 j cap plus k cap. Now both these are intersecting orthogonally. So what we obtain is that lambda minus 2 into minus 8 minus 2 into 4 plus 1 into 12, this is equal to 0, and this gives us lambda is equal to 5 by 2. So we have obtained the values over here. One is lambda is equal to 5 by 2, and second we are obtaining that mu is equal to 1. So these are the required values of lambda and mu. Next we have is show that gradient of the function a vector dot r vector over r raised to the power n, it is equal to this value, where we are saying this a vector is some constant vector and r vector it is given to us. So to calculate this value, we are writing gradient of a vector dot r vector over r raised to the power n, this is equal to sigma I cap curly by curly x a vector dot r vector over r raised to the power n. Now a vector is a constant vector, so we can write this is equal to sigma I cap. A vector is constant vector, so we are writing a vector by r raised to the power n. Derivative of r vector, it is I cap. R vector we have it is x I cap plus y j cap plus z k cap. So curly r vector by curly x, that is equal to I cap. Then we are having it is minus n by r raised to the power n plus 1 curly r by curly x into a vector dot r vector, and this whole term we are having in bracket. How we are getting this? We are saying we are considering this a vector by Rn as first function and this r vector as second function. A vector is constant, we obtain in this way, and the derivative of 1 by r raised to the power n, this is the derivative of 1 by r raised to the power n in term with respect to x. So we are saying this value is equal to, we are writing this value is equal to 1 by r raised to the power n common, we are left with this a 1, because a vector, we are saying a vector dot I cap, that will be equal to a1 I cap plus a2 j cap plus a3 k cap dot I cap, so that is equal to a1. So we are saying this value is equal to a1. This r raised to the power n we have already taken common, we are left with this I cap. So we are writing over here it is a1 I cap. Then the next term we have taken r raised to the power n common, so we are left with this r, and the answer we are writing it is minus n by r raised to the power n plus 1 sigma x I cap upon r into a vector dot r vector. We are using the result over here that r square is equal to x square plus y square plus z square. So del r by del x is equal to x by r. This value we have it is x by r. We are writing it in this form. we have this I vector over there and we obtain the answer in this form. So we are writing that the gradient of A vector dot R vector divided by R raised to the power n, this is equal to A vector by R raised to the power n. Look at this value. This is, we are writing it is A I cap plus A2 j cap plus A3 k cap. We have this summation over here, so we are writing it is A vector. And the next term we are left with is minus n into A vector dot R vector into, look at this value now, x I cap plus y j cap plus z k cap. This is the value of R vector divided by the power we have over here n plus 2, and this is the result that we have to prove. This is the result that we have to prove. Next is find the angle between the surfaces this and this at the point 1, 1, 0. So clearly both these surfaces, they intersect at this point. So this point will satisfy both these equations. So we get A plus 1 minus 1 is equal to 1. So this implies us that the value of A is equal to 1. This point, it satisfies this equation also. So we get it is B plus 0 is equal to 1. This implies us B is equal to 1. So the two surfaces that we have, the two equations that we have, it is x square plus y square plus z square minus xy minus 1 is equal to 0. This is phi 1 we are writing. Phi 2 we have x square y plus y square z plus z minus 1 is equal to 0. Now if we calculate the values of gradient in both these cases, we are writing gradient of phi 1, that will be equal to 2x minus y I cap plus 2y minus x j cap, and last we have is 2z k cap, and the gradient of phi 2 if we calculate, that is equal to 2xy I cap, then it is plus x square plus 2yz j cap, and then it is y square plus 1 times k cap. Now if we substitute the values over here, we are saying the point that are given is 1, 1, 0. We obtain that the gradient of phi 1, suppose we are saying this is the point P, that is equal to, we are substituting 1, 1, 0. We are left with this I cap. Next value we are left with is plus j cap. Similarly in this case we are saying gradient of phi 2 at the point P, that is equal to, when we substitute 1, 1 over here, we obtain it is 2 I cap. Next value we obtain, that is equal to plus j cap plus 2 times k cap. Now we have to calculate the angle between these two. So to calculate the angle between these two, we are writing it is cos theta, it is cos inverse of dot product of these two, I plus j dot 2i plus j plus 2k divided by modulus of I dot I plus j modulus of 2i plus j plus 2k. So we are getting this is equal to 2 plus 1 divided by the modulus of this value, it is square root 2, and the modulus of this value, it is 4 plus 4 8 plus 1 9, it is 3. So the answer we are getting, it is 1 by root 2. So we are saying this is cos inverse of this, cos inverse of this, and the answer we obtain, that is equal to pi by 4. So we are saying that the angle between these two surfaces, it is pi by 4. Next we have is prove that the gradient of integral of r raised to the power n dr, that is equal to r raised to the power n minus 1 into r vector. Now if we calculate this integration of this, we obtain this is gradient of r raised to the power n plus 1 by n plus 1 plus c. So this is equal to sigma I cap curly by curly x r raised to the power n plus 1 over n plus 1. The derivative of this c will be 0. So we are writing this is equal to sigma I cap this n plus 1 by n plus 1 r raised to the power n curly r by curly x. These two values get cancelled. And the value of curly r by curly x, we know it is x by r. So we are getting sigma I cap r raised to the power n into x by r. We are writing this is equal to r raised to the power n minus 1 sigma I cap x. So this is equal to r raised to the power n minus 1 into r vector. R vector means we are saying it is x I cap plus y j cap plus z k cap. So this is this sum. So we are writing it is basically equal to r vector. So this is the required proof. So we have proved this result. Next is find the unit vector normal to the surface this at the point 1, 2, minus 1. We have to find the unit vector normal to the surface. It means we have to find the direction of the gradient at this point. So if we are writing this surface phi is equal to x cube plus y cube plus 3xyz minus 3, and we write the gradient of phi that is equal to 3x square plus 3yz I cap plus 3y square plus 3xz j cap plus 3xy k cap. Now if we substitute this point, if we substitute the point 1, 2, minus 1 in this equation, we obtain this value is equal to minus 3 into I cap minus 3 j cap minus 2k cap. This is the value of the gradient of phi at the point 1, 2, minus 1. So we have to find the unit vector. So unit vector corresponding to this, it is I cap minus 3 j cap minus 2k cap divided by, we have plus minus sign over here, modulus of I cap minus 3 j cap minus 2k cap. So the answer we obtain it is plus minus 1 by root 14 into I cap minus 3 j cap minus 2k cap. So this is the unit vector normal to the surface x cube plus y cube plus 3xyz is equal to 3 at this point. Now the next question we have is determine the constant A such that at any point of intersection of the two spheres, these are the equation of two spheres, their tangent planes are perpendicular to each other. So we are talking about two surfaces. First surface, it is phi is equal to x minus a square plus y square plus z square minus 3, and phi 2 we have, that is x square plus y minus 1 square plus z square minus 1 is equal to 0. This is equal to 0. So if we calculate the gradient of both these, we obtain gradient of phi 1. When you solve this value, you will obtain it is 2x minus a I cap plus 2y j cap plus 2z k cap, and the gradient of phi 2 we have, it is 2x I cap plus 2 into y minus 1 times j cap plus 2z times k cap. Now suppose we are saying that both these tangent planes, they intersect, or these two spheres we are saying they intersect at the point x, y, z. Then at this point x, y, z, the dot product of these two is 0. So we obtain 4x into x minus a plus 4y into y minus 1 plus 4z square. This is equal to 0. So this 4 gets cancelled. and we are left with is x square plus y square plus z square minus ax minus y is equal to 0. Now clearly we have this point x, y, z. It lies on both these surfaces. So if we calculate the value of phi 1 plus phi 2, we obtain that is equal to, if you solve this value, it is x square plus a square minus 2ax plus y square plus z square minus 3. Then it is x square plus y square plus 1 minus 2y plus z square minus 1 is equal to 0. We are adding these two equations. The answer we get it is 2x square plus 2y square plus 2z square minus 2ax minus 2y. We are having this 2ax minus 2y. This 1 and 1 gets cancelled, and we are left with this plus a square minus 3 is equal to 0. So we have two equations. One is this equation. It is x square plus y square plus z square minus ax minus ay is equal to 0. And second is this equation. Now if we substitute the value of this equation in the second equation, we obtain, this implies us this whole value. Look at this whole value. This is 2 times 0 plus a cube minus 3 is equal to 0. So this gives us that the value of a is plus minus square root of 3. So this is the required value of a. We have to calculate the value of a. So it is plus minus square root of 3. Next we have is, if a vector and b vector are constant vectors. These are two constant vectors and the value of r vector is given. We have to show this result. We have to prove this result. So we start with the innermost term over here. It is gradient of 1 by r. We solve this term. So it is, we are saying gradient of 1 by r. So that is equal to sigma I cap curly by curly x into 1 by r. So this is equal to sigma minus 1 by r square curly r by curly x I cap, and we know that the value of curly r by curly x, it is x by r. So we are getting it is minus 1 x by r cube into I cap, and this value is equal to minus 1 by r cube into r vector. We have vector over here. Now the next term we have is its dot product with a, and we are taking the gradient of this whole term. So if we take the dot product with a, we obtain, we are talking about this term, it is gradient of a vector dot, this value we are saying minus 1 by r cube into r vector. We can write this is equal to sigma I cap curly by curly x a vector, and it is dot product of 1 by r cube into r vector. So we can write this is equal to sigma I cap. This term we can write, it is curly by curly x a vector dot r vector over r cube, and it is minus sign over here. So if we differentiate this term, we have already seen in our previous questions, it is equal to sigma I cap. When we are differentiating, we are getting a vector dot I cap over r cube plus 3 by r raised to the power 4 curly r by curly x into a vector dot r vector. Now the value of this term is curly r by curly x. We know it is x by r. So this value we obtain, this is sigma I cap minus of a vector dot I cap over r cube plus 3 x over r raised to the power 5 a vector dot r vector. Now what is a vector dot I cap? This will give us a1. We are having this term over here, so we get this is equal to sigma a1 I cap. So when this I cap is multiplied over here, when we have taken the sum, we will get this is minus a vector over r cube plus 3 times we have a vector dot r vector divided by r5, and it is sigma xi. This will give us the value of, its value is r vector. Now next thing we have to do is we have to take its dot product with b and multiply it with r raised to the power 5. We are taking the dot product with b, we are talking about the term r raised to the power 5 b vector dot gradient of a vector minus 1 by cube r vector. This is equal to, we are saying this is r raised to the power 5, this is not r vector, this is r raised to the power 5. So we are getting r raised to the power 5 and dot product with b when we are doing, it is sigma minus a vector, and the sigma is being removed, this sigma is not there. We are saying minus a vector dot b vector over r raised to the power 3 plus 3 into a vector dot r vector dot b vector over r raised to the power 5. So this is equal to 3 times a vector dot r vector into r vector dot b vector, this term r raised to the power 5 get cancelled, minus a vector dot b vector into r square, and this is what we have to prove. Now next we have is a paraboloid of revolution has the equation 2z is equal to x square plus y square. We have to find the equation of the normal and tangent plane to the surface at the point 1, 3, 5. So we are writing that phi is equal to x square plus y square minus 2z is equal to 0. So if we calculate the value of gradient of phi, we are getting it is 2xi cap plus 2yj cap minus 2 times k cap. This is gradient of phi. Now we have to calculate the value of gradient of phi at the point, this point we are saying it is p. So we are saying gradient of phi at p, that will be equal to 2i cap plus 6j cap minus 2 k cap. Now we have to find the equations of the normal and the tangent plane. So when we are saying the normal, so the direction of the normal, it will be parallel to this. So the equation we will obtain, that will be x minus 1, these are the points, x minus 1, the direction cosines if we write over here, or direction ratios we write, it is 1, this is 3 and this is minus 1, these are the direction ratios. So we are writing this is 1, is y minus 3 over 3, that is equal to z minus 5 over minus 1. So this is the equation of the normal, and when we are writing the equation of the tangent plane, that will be x minus 1 into 1 plus 3 into y minus 3 plus minus 1 into z minus 5, this is equal to 0. So we get x plus 3y minus z, that is equal to, the values we are getting, it is minus 1, minus 9 plus 5. So we are left with this minus 5. So this is the equation of the tangent plane and this is the equation of the normal. Next is find the directional derivative of this function at the point 1, 1, minus 1 in the direction towards minus 3, 5, 6. So directional derivative means we are saying we have some surface over here. This is the point given 1, 1, minus 1, and we want that there is another point over here minus 3, 5, 6. We want to find the directional derivative in this direction. We are talking about this is the normal. The direction of this normal is given by the gradient of phi. This is n cap. This is n dash cap. So basically we want to find the projection of this gradient towards this line. So first of all we are calculating the gradient over here. So del of f, that is equal to 3e raised to the power 2x minus y plus z, partial derivative with respect to this term will remain as it is. Then we will get it is 2i cap minus j cap plus k cap. Next we are calculating the direction, the gradient at the point 1, 1 and minus 1. So the answer we are getting, that is equal to, when you substitute this value you will get 1 minus 1 and this is minus 1, so this will become 0. So we are getting it is 3 into 2 I cap minus j cap plus k cap. So this is the gradient. Gradient is, this gives the direction of this gradient. This is basically giving us the direction of the normal vector. Now we want to find its projection towards this line. So what we obtain is the projection towards this line. It will be given by, we want the direction ratios corresponding to this. So direction ratio corresponding to this, it is minus 3 minus 1, then it is 5 minus 1, and then it is 6 plus 1. So we are getting it is minus 4, 4 and 7. So projection of this gradient along this direction, that will give us the directional derivative, that is equal to gradient of f about p dot pq vector. This point we are saying this is p, and this point we are saying this is q. We are saying pq vector over length of the pq vector. That is, we require only the direction over here. We require direction cosines. So the answer we will obtain, that is equal to the dot product of these two, that will be 3 into minus 8 plus 4 plus 7 divided by, and this value we have it is 16 plus 16 plus 49, and square root we get it is 9. So the answer we obtain, that is equal to minus 5 by 3. So this is the directional derivative of this function at the point 1, 1 minus 1 in the direction of this point. Next is find the directional derivative of this function at the point this in the direction of line PQ. This thing is given. In what direction it will be maximum? The answer for this we know, it is in the direction of the gradient, and find the maximum value of it. So first of all we are calculating the gradient of phi. So gradient of phi we have it is 2x I cap minus 2y j cap plus 4z k cap. Now if we calculate the value of gradient at the point 1, 2, 3, the answer we obtain it is 2 I cap minus 4 j cap plus 12 k cap. So this is equal to 2 times I cap minus 2 j cap plus 6 k cap. Now if we are saying this is the point P and Q, then the direction of the PQ vector we are saying, that is equal to 5 I cap plus 4 k cap minus I cap plus 2 j cap plus 3 k cap. The answer we will get, that is equal to 4 I cap minus 2 j cap plus k cap. So the directional derivative of this phi in the direction of P, this line PQ, that will be given by gradient of phi at P dot PQ vector divided by the length of PQ vector. So answer we obtain, that is equal to 2 into, we are taking the dot product of these two vectors. The answer we are getting it is 4 plus 4 plus 6 divided by the mod of this is 16 plus 4 plus 1 square root. So we are getting it is square root of 21. So if we solve this, we rationalize this, we get it is 4 root 21 by 3. This is the directional derivative in the direction of PQ vector. The answer for the second part, what directional derivative, in what direction the directional derivative will be maximum? So it will be maximum in the direction of this gradient. It will be maximum in the direction of this gradient. It means we are saying the direction cosines, direction ratios, they are 1, minus 2 and 6, and find its a maximum value. Now maximum value of this means we want to find the, we are talking about this value, we want to calculate the modulus of this value or length of this vector. So length of this vector, it is given by 2 square root of 1 plus 4 plus 36. So answer we get 2 root 41. So this is the maximum value of the directional derivative. Next is for the function phi is equal to this. Find the magnitude of the directional derivative along a line making an angle 30 degree with the positive x-axis at the point 0, 2. So first of all, we are going to calculate the gradient of this function. So to calculate the gradient, we are calculating gradient of phi, that is equal to curly by curly x over x square plus y square I cap plus curly by curly y x over x square plus y square j cap. Z term it will be 0. So when we differentiate these terms, we will get it is x square plus y square whole square. The derivative we will get it is x square plus y square. Derivative of x is 1, then it is minus 2x square, this is I cap, plus x square plus y square whole square, and we have 2xy j cap. So the answer we are getting it is 1 over x square plus y square whole square into y square minus x square I cap minus 2xy j cap. So the directional derivative at the point, we have to calculate it at the point 0, 2. So we are saying the directional derivative, a gradient along the point 0, 2, that will be equal to, when you substitute this value, you will get it is 1 by 16. 0, 2, when you will substitute this value will become 0, and this value will become 4 I cap. So we are writing it is equal to 1 by 4 I cap. Now we have to calculate the directional derivative in the direction of the line which makes an angle of 30 degree with the positive direction of x-axis at the point 0, 2. So we are saying that equation of that line, that will be x minus 0 over cos 30 is equal to y minus 2 over sin 30. So this implies as x over root 3 is equal to y minus 2 over 1. So we are saying that this line, it is parallel to the line whose direction cosines they are root 3, 1. So this is the value of the gradient at this point. We want to find the projection of this gradient along this direction. So the value we obtain, that is equal to 1 by 4 I cap dot root 3 I cap plus j cap divided by mod of root 3 I cap plus j cap. So answer we get for this, it is equal to root 3 by 4 plus 0 divided by the value we get over here, it is 3 plus 1, it is square root of 2, this is 2. So we get it is root 3 by 8. So this is the value of the directional derivative along this line. Now next we have is, if the directional derivative of this function at a point 1, 1, 1 has the maximum magnitude 15. So maximum magnitude 15 means this is the value of the modulus of gradient of phi, that is given to be 15 in the direction parallel to the line this. So we are saying that the direction of this, it is 2, minus 2 and 1. This is the direction of this gradient. Find the values of A, B and C. So if we calculate the value of the gradient from this term, we get gradient of phi, that is equal to 2axy plus cz square I cap. Then it is with respect to y, when we differentiate, it is ax square plus 2byz j cap, and last term we are getting it is plus by square plus 2czx times k cap. Now if we calculate the value of this gradient at the point 1, 1, 1, the answer we obtain, that is equal to 2a plus c times I cap plus a plus 2b times j cap plus b plus 2c times k cap. Now this is the gradient, this is the value of the gradient, and the direction of the gradient is given to be 2, minus 2 and minus 1. So both these values, these are proportional. So we get that 2a plus c over 2, that is equal to a plus 2b over minus 2, that is equal to b plus 2c over 1. Both these values, these are proportional because both these lines, these are parallel to each other. These are not lines, we are saying both these vectors, they are parallel to each other. Now we have obtained these equations, and if we simplify these values, we obtain these two equations in A, B and C. So these are two equations in three unknowns, and when we solve these two equations, these calculations are shown over here, you will obtain the relation between A, B and C. And suppose we are getting the answer in this form, we are getting the value of A by 4 is equal to B by minus 11 is equal to C by 10, and if we equate it equal to mu, we obtain that A is equal to 4 mu, we obtain B is equal to minus 11 mu, and C is equal to 10 times mu. So these are the values of A, B and C that we obtain over here. Now if we substitute these values of A, B, C in this equation, we obtain the gradient of phi at the point P. It is given by 9 mu 2 I cap minus 2 j cap plus k cap. And what is given to us? This value. We are talking about this value, that the maximum magnitude of this, it is 15. It means the magnitude of this gradient, it is given to be 15. If we calculate the magnitude of the gradient, we get it is 9 mod of mu square root of 4 square plus 4 square plus 1, and this value is given to be 15. So from this we get mu is equal to 5 by 9. So the value of A we obtain, it is 20 by 9, B we obtain that is minus 55 by 9, and C we obtain that is equal to 50 by 9. So this is one answer we are obtaining. Now second case, we are saying that if we would have assumed this is the equation of the line given, if we take that the direction of this line, it is given by, it is parallel to this vector, it is minus 2i plus 2j minus k cap, then we obtain that the values of A, B, C, they are, the signs of all these values, they are reversed. So we are saying that the values A and B, they can take, it can be either this set, or we are saying it is either this set. So these are the values, required values of A, B and C. Now next we have is find the directional derivative of the function phi is equal to xy square plus yz cube at the point this along the direction normal to the surface this at the point 1, 2, 2. So to find the directional derivative, we are calculating the gradient of this function phi. The answer we get, it is y square I cap, then it is plus 2xy plus z cube times j cap, and last we get it is plus 3yz square times k cap. So if we calculate the gradient at the point 1 minus 1 1, the answer we obtain, it is I cap minus j cap minus 3 times k cap. Now we have to find the gradient in the direction normal to this surface at this point. So we have to find the normal to this surface, it is given by gradient of f. We are writing the value of f is equal to x square plus y square plus z square minus 9. We are getting it is 2x I cap minus 2y plus 2y j cap plus 2z k cap. If we calculate this gradient at the point 1, 2, 2, we are saying 1, 2, 2, the value we obtain, 2 is common, we are left with this I cap plus 2 j cap plus 2 times k cap. This is the gradient of f at q. Now the direction of this, it is 1, 2, 2, these are the direction ratios. Now we want to calculate the the value of this gradient, the projection of this gradient in the direction of this these direction ratios, corresponding to these direction ratios. So the answer we obtain, it is gradient of phi at the point P dot these direction ratios, it is I cap plus 2 j cap plus 2 k cap divided by the length of this vector. So the answer we obtain, that is equal to 1 minus 2 minus 6 divided by square root of 1 plus 4 plus 4. So that is equal to minus 7 by 3. So this is the directional derivative along the normal to this surface. Next we have is find the directional derivative of the scalar function this at a point this. So suppose we are talking about this is the function, this is the point P, that is 3, 1, 2, and the direction of the vector is given. We are saying there is another vector, this is the point Q over here, and the direction of this is given to be YZ, ZX, XY. So if we talk about this point P, this direction, this will be given by, if you substitute these values over here, you will get it is 2, 6 and 3. So these are the direction ratios of this line PQ corresponding to this point, because this point P that will satisfy these values, the values of these direction vectors. So we are going to calculate first the gradient of phi. So that will be equal to sigma I cap curly by curly x. What is this value? This is basically the value of 1 by r. Answer we get, this is sigma minus I cap 1 by r square curly r by curly x. This is equal to sigma curly r by curly x is x by r. So we get x over r cube I cap, and this is equal to minus r vector over r cube. So this is the value of gradient, and we are writing this is equal to minus x I cap plus y j cap plus z k cap divided by x square plus y square plus z square raised to the power 3 by 2. Now if we calculate the value of this gradient at the point 3, 1, 2, we calculate the value of the gradient at the point 3, 1, 2, the answer we obtain, that is equal to minus 1 by 14 raised to the power 3 by 2, 3 I cap plus j cap plus 2 times k cap. Now we have two values. One is, this is the value of the gradient, and this is the direction in which we want to find the projection. So when we calculate the projection over here, the answer we obtain, that is equal to minus 1 by 14 root 14 into the dot product of these two will give us 6 plus 6 plus 6 divided by the value we have over here, square root of 4 plus 36 plus 9. So answer we get for this, it is 7. So we get it is minus 9 by 49 root 14. So this is the value of the directional derivative of this function in the direction of this vector. Next is find the directional derivative of this function at a point P111 in the direction of this line. In the direction of this line means the direction ratios, they are 2, minus 2 and 1. So if we calculate the value of gradient of phi, the answer we get, it is equal to 10xy minus 5 by 2z square I cap. Then we get it is 5x square minus 10yz j cap, and then it is plus, with respect to z when we are doing, it is minus 5y square plus 5zx times k cap. Now we substitute the value. We have to calculate this gradient at the point 1, 1, 1. We have to calculate the value at 1, 1, 1. So the answer we obtain at this point P, it is 5 by 2 into 5 I cap minus 2 j cap. Now we want, this is the value of gradient of phi at the point P. Now we want to calculate the projection along this direction. So the answer we obtain, it is 5 by 2 into, when we do the dot product over here, we obtain 10 plus 4 divided by the values we have, it is square root of 4 plus 4 plus 1 So the answer we obtain, that is 35 by 3. So this is the directional derivative that we have over